Okay, so this table is very much helpful to understand how the capacitor is charged. Uh, After one time constant, capacitor is charged to 63%, after second 86, after third 95, after fourth 98, after fifth 99. So at this position we consider it at fully charged, because after this there is a very minor change if the time is passed on. And similarly, current is 100% at start and it's almost zero after five time constants. So we say at this position, the capacitor is fully charged and there is no more flow of current. So same values we will verify. These are calculated using an equation. We will verify these values using the multisim. So initially we have to build a circuit using the multisim, and that circuit will be exactly like which is already shared. So circuit is already shared in the handout like this. So we need a resistor, a capacitor, a battery, and a switch. This switch is called single pole double throw. That means there is one common terminal and another terminal can switch in between two positions. So let's start with multisim, taking some DC voltage, making its value simple 10 volt, because 10 volt will have the 63% as 6.3. So in percentage, this will be easy to understand. Similarly, a resistor, a capacitor, okay. So by default, whatever the values are, 1 kilo ohm, 1 microfarad. So if we calculate their time constant tau, so can anyone tell how much will be the time constant of this circuit tau? We have to also add a switch, a SPDT switch to control the charging and discharging. Yes. Okay. PPT will be. Okay. This is 1 kilo. That is 1 into 10 is power plus 3. 1 microfarad. This is 1 into 10 is power minus 6. So tau, time constant, product of R and C will be how much? SPDT switch. So if we don't know where the component is, select all groups, all families, SPDT, and here we got the switch. This is the common point of the switch which should be connected towards the circuit. So rotate it two times, and this is connected with this resistor, upper side with the supply, and the lower side with the negative, and connect the ground again on the negative side. So circuit is completed with this. Now we just need oscilloscope to observe the same thing. So here the fourth one is oscilloscope. We will place oscilloscope over here. This is just like a multimeter. There are two channels to see the waveforms. So we can use channel A or B, and we have one capacitor, so we need only one channel. So connect this channel across this capacitor and that's all. And now we can see the waveform using oscilloscope. So yes, this tau will be 1 millisecond. Yes. Now open the oscilloscope and now we can run the simulation. Initially, this switch should be placed down so that during running the simulation we can move it up and the capacitor should be charged. So in this position capacitor will be charged, in this position capacitor will be discharged. Now let's see this. Let's run the simulation. Now there are some settings in this oscilloscope. This is time base. We have to select the time base in a way so that our waveform should be visible. Similarly, channel A voltage setting are scaling. Channel B voltage setting are scaling. We have to set in a way so that we can see that waveform within this window. Now, let's start charging. So, as we move the switch up, capacitor started charging from 0 volt to this point, which is 10 volt. Why? Because our setting is 5 volt per division. This is 1 division. So the waveform has gone up to 2 divisions. This means this has reached the maximum supply voltage of 10 volt. Now how to verify this? In order to verify, first of all, let's reduce the time base to zoom the waveform horizontally. With reducing the time base, waveform will be zoomed horizontally. And this will be easy for us to do measurements. Still reducing the time scale, more reducing the time scale. Number one, observation number one, which we can see that this charging behavior is exponential. Number one, this is not a straight line. This is increasing, but in an exponential way. Number one. Number two, we have to verify these values. That after one time constant, this should be 63%. So as per our supply voltage, the capacitor should have 6.3 volt. Similarly, after two time constants, this should have 86%, means 8.6 volt. And similarly, after 5 time constant, 99% means capacitor should gain 9.9 volt. Let's try to verify it. These are the cursors which will help us to measure the voltage. Now, the first cursor we have to place at the starting point of the charging. So charging is started from this point. So we have to place this first cursor over here in a way that also we can slightly move the cursors from here. T1 for cursor 1, T2 for cursor 2. So we can slightly move a point before where there is millivolt. So a point before there are picovolts. So this is assumed as a 0, our starting point. And this point we have to place at one time constant. So the time constant of this circuit is 1 millisecond. So we will place the second cursor, T2 minus T1. The time difference should be 1 millisecond. So at that point, we will note the voltage. So it's not necessary that we can exactly place it at 1 millisecond. Let's try to put it on nearest point of 1 millisecond. So the nearest point to 1 millisecond is this 1.004 milliseconds. And at this point, the voltage is 6.28, which becomes 62% of 10 volt. Ideally, this should be 63%. Here, this is 62%, and that's okay. This is proved. Similarly, at second time constant, two time constants, this should be 86%. Let's try to verify. At 2 milliseconds, this should be 86%, or 8.6 volt. And this is 2 milliseconds, this is 8.6 volt. Similarly, at 3 tau, this should be 95%. 3 milliseconds. We have set actually the value of tau as 1 millisecond. So it's very easy to observe this. So yes, this is 3 milliseconds. This is 9.5 volt or 95%. 4 tau, 98%. 4 tau means 4 milliseconds in our case. And this is 98%. Finally, at 5 tau, we assume this is fully charged condition. So 5 tau, that means 5 milliseconds. This should be 99% or 9.9 volt. And here it is 5 milliseconds, 9.9 volt are 99%. Also, we can see from this curve that here charging is continuous. Now, from here, this straight line shows that capacitor is fully charged and the charging is maintained now at the full supply voltage, which is 10 volt or 9.9 volt. So, what we have to do, we have to take different values of resistance and capacitance. We have to note that time, that how much is 1 tau, 2, 3, 4, 5, what is the voltage at these points, and what is the percentage of that voltage in this column. And that's all. With this, our lab is completed. So you will also go through the applications which are shared in the PPT. So hopefully this will be an interesting lab experiment. Also, you are welcome for any uh, questions or discussions. Thank you for listening.